Alrighty, we're going to be starting on slide 13 for our next video. So these are actually special line types. So if you'll notice here, our equation of our line is just y equals 5. So it's missing an x. What that means is that really all of these y's are going to equal what number? Hopefully you recognize that they're all going to equal 5. So regardless of -2, -1, 0, 1, and 2, regardless of what our x number is, y is always going to be 5. So that means this column is going to be 5 no matter what our x number is. Okay? So these ordered pairs would be -2, 5, -1, 5, 0, 5, 1, 5, and 2, 5. So again, no matter what number we're looking at for x, our y value is always going to be 5. So if we quickly plot these, you're going to see something kind of unique that happens with each of these, okay? So -2, 5, that'd be here, left 2, up 5. -1, 5 would be right 1, up 5. 0, 5 would just be going up 5 on the y-axis. 1, 5 is going to be here. And 2, 5 is going to be here. If I connect all of these points, they make a unique line. Okay? So when we have, and this goes to this next slide here, okay? So I'm going to jump over to slide 14. In general, what is the graph of an equation in the form of y equals a? I also just like to rewrite this as y equal to some number. So whatever number y is equal to, our graphs are always going to be what we call a horizontal line. Okay? Horizontal lines are always going to be lines that are like this. So flat, left to right. And they're going to be at the y value. So whatever our y value is that it's equal to, it's going to be a horizontal line at that value. So like the last one, it was at y equals 5. So I put a point at where y is 5 and then draw a horizontal line through it. Now, looking at this next slide here, this is talking about an x equals number equation. So now this is talking about x equals -2. So if we read in the previous example that equations of the form y equals a, or just y equal to some number, they have graphs that are horizontal lines, okay? So y equals a number is left to right graphs. Equations of the form x equals a, or x equal to some number, they have graphs that are vertical lines. So a vertical line looks like so. So the graph of x equals -2 is a vertical line through -2, comma, whatever y for any number y. So just as a reminder, these are our x values. That's our x-axis. -2 and our x is going to be right here. Okay? So if I go ahead and draw a vertical line through that, so up and down, that's going to look like so. Okay? So just as a recap, I'm going to write this down here at the bottom, just so we have a little note for it. When we have y equals a number, we're going to get horizontal lines like so. When we have x equals a number, we're going to get a vertical line. Okay, so that's kind of our main idea for these special line types here. Okay. Now there are 2 examples on the next page, so I'm going to go through those. We're going to skip slide 16. Okay. So slide 17 here, we're going to graph 2 different examples. One is an x equals, one's a y equals. Okay, so x equals 6. Anytime we have x equals, we're going to have this up and down graph through where x is 6. Okay, our x-axis is this one right here. So we're going to go right 6. 1, 2, 3, 4, 5, 6. Put a point. And then we're going to draw a vertical line through that point. So a line up and down. That's where our x equals 6 graph is going to be. Y equals -3. That's going to be a horizontal line, but now we're looking at our y axis. Y-axis is the one that's up and down. So I'm going to go -3 in the y, so that's down 3, put a point. And then we're going to draw a horizontal line through that one there. Okay, so that's first piece of today. Second piece of today is talking about graphing using these things called intercepts. So this is the second concept of 4.1. So 4.1 is tables, but then it's also looking at the intercepts of a graph. So on slide 18, you can graph a linear function given only 2 points on the line. Using the x and y intercepts is common because they are easy to find. The intercepts provide the ordered pairs of 2 points through which the graph of the linear functions passes. So in module 3, we talked about x and y intercepts. Okay, what these are, I'm just going to write a little note off to the side here. This is where the graph crosses the x and y axis. So it's where our graph is crossing through the x and y axis. Now, the reason these are easy to find is because this is where x and y equal 0. So we can easily find these because we can use x and y as being this number 0 to find the 2 points that this line would go through. So this does require a little bit of algebra maths, but it's a lot of just using calculators, okay? So on slide 19 and 20 kind of go together. So our equations are going to be written slightly different when we're working with intercepts, okay? So here's our equation for this first problem, and it says graph by using the x and y intercepts. So to find the x-intercept, what we're going to do is we're going to make y equal to 0, okay? So I'm going to copy down our original equation. I'm going to add one thing in front of that x. I'm going to add a negative with a 1 there because that is the number -1 if you like seeing a number with the x there, okay? Now what we're going to do is we're going to let y equal 0. So what that means is I'm going to take this y out, and I'm going to make it the number 0, but then everything else is going to stay the same. So the 2 in front of that 0 is going to come down, the -1x will come down, and the equals 8. Now something nice happens here. In the middle, I've got 2 times 0. Any number times 0 is going to be 0. So what happens is these actually cancel off, and all I'm left with is the -1x equaling the number outside, which is 8. And now I just have an easy problem to solve for x. Anytime there's a number in front of a variable, we're going to divide by that number. So divide by -1 on both sides. And that's going to get me x equals -8. So what this is telling me is that my x-intercept is -8, or the point -8, comma 0 for y, because we said y was going to be 0. That's one of the points that we're going to be plotting, okay? So we'll just kind of leave this thing off to the side here for now, and we're going to use it later. Now again, we're going to do the same thing to find the y-intercept, but we're going to let x equal 0. So this one, we made y 0. This one, we're going to make x 0. So again, I'm going to rewrite our equation. -1x plus 2y equals 8. This time, we're going to take out the x and make it a 0. And then everything else in yellow is going to stay. So -1 plus 2y equals 8. Now the beginning stuff cancels out because -1 times 0 is 0. I'm left with a positive 2y equals 8. And then again, we have an easy equation to solve. We're going to divide by 2 in front of y. 8 divided 2 is 4. Now from this, my y value is 4 and my x was 0. So now my 0 is first, my number I got is second. So that 4 goes second. Now this is the hard work. Easy now is what we're going to do. We're going to actually now graph these, okay? So looking at this next slide over here, once you find your intercepts, the next piece with the graphing is you're just going to graph them. So we said the x-intercept was at -8, 0. Again, this is our x-axis. -8 would be left 8, and then we don't move up or down. So we just leave our x-intercept here. That's at -8, 0. Our y-intercept was 0, 4. So our y-axis is here. So we're going to go up 4, put a point. That's our y-intercept. And then what we can do now, those are the only 2 points we need. We can go ahead and connect them and call it good. So that's it. So the hard part is getting those 2 values, and then the easy part is then once we can actually graph them. Okay. So we're going to look at one more example here, and then we'll kind of move on from there. So looking at this last example, on slide 21, again, here's our equation. Okay, so we're looking at 12x plus 4y equals 36. That's our equation. And we're going to let y equal 0 for the first one. My equation, I'm just going to rewrite. Okay. Now we're going to take out the y and make it a 0. Okay. We'll bring everything else down. Okay, and then now from here, the middle stuff cancels. 12x comes down equals 36. Divide by the number in front of x, and we get x to be 3. So that is our x-intercept, and if we want to write that as a point, it's going to be 3, 0. Now we're going to do the same exact thing, but let x equal 0 this time. So again, rewrite our equation, 12x plus 4y equals 36. Now we're going to take out the x and make that a 0. Bring the 12 down in front. Now the beginning stuff cancels out. 4y equals 36. Divide by 4. And we get y to be 9. If we want to write that as an ordered pair, it's going to be 0 first, then 9. The next slide goes directly with that. Okay, so we can go ahead and graph those 2 points. So the x-intercept was that 3, 0. If it helps, we can write that here as well. And then the y-intercept was 0, 9. So if that helps you to see those 2 values there. So 3, 0 for x is going to be right here. 0, 9 for y is going to be right here, up 9. Again, those are the only 2 points we need. We'll go ahead and connect them with a line. Make sure you have your arrows, and then we should be good to go. I'm saving the next example for the next video because that actually deals with the practice for that piece.